Okay, good. Hi everybody, hi folks. Super happy to be here and to present you Anon Aadhaar. So who we are. So I guess you had the ETHIndia before, so you got introduced like to PSE. So PSE, we are like a research and development laboratory, like financed by the Ethereum Foundation. We are working on stuff like ZK, MPC, and FHE. And Anon Aadhaar is one of the PSE projects. So basically, Anon Aadhaar is a protocol to let any Aadhaar citizen being able to signal themselves privately using ZK snarks. So what is the current problem that we are trying to solve here? So basically, when you're doing like a KYC, usually you need to reveal your full identity. So I think that most of you guys are like now used to like give your whole Aadhaar, someone taking a photo of it, and then you don't know what they are doing with it. They are storing it somewhere, and you have like photos of your Aadhaar everywhere. Also, like this is very vulnerable to hacks and privacy leaks. So there has been in the past like huge like database of like sensitive identity data that was leaked on the internet. And also, one angle that we are like working toward too is that when you want to signal yourself like as a human on chain, there is no perfect solution, and we think that actually like leveraging identity documents and the digital signatures that are contained inside of that document, they are like a good solution to explore. So here is not to compare with other solutions, it's just to have for you like a mapping about like when we want to have like Sybil resistant or like proof of identity on chain, what are like the solution out there. So of course you have biometrics, you have like aggregation theory, basically if you can show me that you have activities like on many platforms, then I can derive some type of score, and based on that score I can assess if you're more or less a human. And actually what we are doing is actually like leveraging directly the digital identity programs. In that case it's Aadhaar, and I'm going to deep dive into how does it works. So this schema is basically what's happening right now in a digital identity program. So here we are not speaking ZK, it's not something that we've built, it's like an architecture that is in place right now in your day-to-day life. So basically what's happening is that you have Alice and Bob. Alice has an identity, and so the government is issuing like Alice an identity and a unique identifier. In the case of Aadhaar, is the Aadhaar number, right? So how can you bring your identity with you? So basically the government is using like digital signature, and in the case of Aadhaar, it's using like also a digital signature. So basically Alice's identity is going to be hashed and signed with a digital signature algorithm. So then at the end of the process, we'll have like a signature, which is the proof of the signature process, and the message containing Alice's identity. Both of these values will be put inside of a QR code. In the case of Aadhaar, it's the Aadhaar secure QR code. And basically anyone, Bob can be anyone, can be you, it can be me, it can be the government, can be like a border. They can read that QR code, get the message, get the signature, get the official government public key on the official website, and verify that signature. So I want you to like acknowledge the fact that actually is the beauty of like asymmetric cryptography here, is that anybody with like the right algorithm and the right public key that is officially published can verify your Aadhaar. So okay, that's cool. But here there are like a problem, right? Because let's say that now like you want to just give a proof to Bob that you're more than 18, for example. And you don't want like to Bob like learn where are you from. Like you don't want Bob to learn your address. In that schema, like the issue is that if Bob wants to learn if your age is above 18, he will have to access the date of birth. But you will have to disclose the whole message basically. So the whole concatenation of your data will be leaked. So that's why we are like Anon Aadhaar is like applying this signature verification with ZK snarks. So why ZK snarks is because like of course you have like zero knowledge property. So basically you can set an input as private here, and it's very succinct. So for all the use cases like for on-chain use cases, it's really like cool because like we can have like cheap verification. For off-chain use cases, it's also great because it's milliseconds instant fast, and also it's secure. So remember our schema. Now the schema is like that one, and basically what is cool with that schema is that now like we can hide the signature and the message. So basically the message containing like Alice's identity is now hidden. So now like what we need to show is like not the signature and the message anymore, but it's basically like a snark proof that we've verified that signature correctly. And then I'm gonna give a bit more detail, but basically like we can now access the data of Alice's like securely. Also, a very important thing here is that everything is happening client side, so no sensitive data is ever leave like the user's computer. So you're not sharing your Aadhaar data with anybody. Everything is all this computation is happening client side. So we are leveraging like the Aadhaar secure QR code. So this QR code can be found like on the e-printed Aadhaar letter, and also you can generate it like on the Aadhaar app. So basically what is that QR code is that you have like a message and a signature. The signature algorithm used is RSA SHA-256. And basically you have all these attributes that are signed. So basically you have like the last 4 digits of your Aadhaar number, your name, your date of birth, your gender, your address, your photo. Yes. So here is like a representation about like what's happening behind the scene. So again, don't be afraid, like we abstracted all that complexity, but I think it's cool for you to have a sense about like how it works and what we are doing. So here we are applying the SHA-256 compression function. We are verifying the RSA signature. And here we need to actually like perform the hash function inside of the circuit because remember we want to access Alice's identity, right? We want to access Alice's identity in plain text and not in the hashed format. So we do what we call selective disclosure, meaning that now that we've verified, we authenticated like Alice's identity by verifying the signature, we can now like extract some value that we are interested about. In the case of Anon Aadhaar, we are like accessing the photo. We are performing like a check that the age is above 18. We are accessing the gender, the state, and the PIN code. All right. So now that Alice's is Anon, we need to actually perform to give her a new unique identifier, and so it's what we call a nullifier. And so here, like we are hashing like what we call a nullifier seed that act as a salt, like so a random value to make sure that Alice's identity will not be compromised if anybody can access like the photo. And we are using the photo. Why the photo is because like we don't want like 2 people resulting in the same nullifier. So photo has enough like entropy, it's random enough, so it can generate like unique identifiers. Then we are like converting the timestamp, so it's the timestamp of the signature, meaning that it's like this data is signed, so we have a strong trust assumption that the data was signed at the right moment. I'm going to explain a bit later like how we can leverage that. And we can also apply like some constraints on some arbitrary values that we call a signal. So again, so that was like the complex part, like how everything is working behind the scene. But we built like a whole experience for you, like to integrate it smoothly to your apps. So we have like all these packages that we are delivering. Basically, like if you want to add this primitive to your apps, it's fairly easy, and it's less than 20 lines of codes. So you just have to import the package. Inside Node.js, you can just generate a secure nullifier seed. Don't do that like inside of your app, just do it on your machine, and then you can take this nullifier seed as the seed of your application. Then you are importing the provider. You can set if you want like to use some test data, or if you want to use like real Aadhaar data. And then you can just import like a very simple login component. And so this login component will look like that. So the user has to give their like QR code in PNG format. Like the prover will have like an interface saying, okay, me the prover, here is what I'm gonna reveal to the verifier. So in that case, we are revealing nothing, just we are generating a proof that you have a legitimate Aadhaar. And we are binding some value to that proof, which is like in that case like an ETH address. So this is, for example, useful if you want to prevent like the proof from being front-run, because if you send the proof in an on-chain transaction, then someone can like listen to that proof before the transaction is executed and basically like impersonate you. So committing to your sender's message address is like preventing from that mechanism. So also from within the SDK, you can access like some features, like again the signal I just explained, and you also have like a selective disclosure. So now that the proof is generated by the prover, what features can you access? So you have the proof. In the case of Anon Aadhaar, we are using Gross 16. So the core of the cryptographic object is like actually what the prover is like giving as a transcript of like what he did. You have like the nullifier, you have the timestamp, you have the public key hash. So here it's really important. So like all the thing is read is that what is mandatory for the verifier to check, because here like the official government public key, UADAI public key, is not hard-coded inside of the circuit, meaning that the circuit is agnostic in terms of public keys. So as soon as you give to the prover like some data that has like the same format as Aadhaar, but is signed with whatever key, it's going to generate a proof. So it's the job of the verifier to check that actually like the signature was like done with the right public key. So that's why it's in red. You need to check the nullifier seed, because if you want to leverage the nullifier feature, then you need to like make sure that this nullifier was like tied to your application and your use case. And then you have the signal hash, so that's optional. And then you have like selective disclosure. So basically, like you can set like custom rules to your verifier. So here I have an example. So basically, we are just initiating like some our core library. Then we are verifying the proof. So here the check is like mainly like just generating the ZK snark. But then now we can add some checks. So here we are like verifying that the public key hash is actually so that is the hash of the real UID public key, for example. So we are just checking that the hash corresponds. You can also, for example, so one main risk, for example, is that you drop your Aadhaar card on the ground and anybody can like access, or you go to a coffee shop to buy a SIM card and the guy has a photo of your Aadhaar and then can read the QR code and like use your QR code to like impersonate you using Anon Aadhaar. So to prevent from that, we have a mechanism. So remember, we have like inside of the signature, we have a timestamp. And so basically you can set a verifier to say, okay, so me, the verifier, I want you to show me a proof with data that was signed like less than 3 hours ago. So that's a proxy that the user has access through OTP to his account and is able to generate fresh data. So then you have, here we are checking the nullifier seed. And here you can add like some checks on selective disclosure. Here this check is like verifying that the user has, the user's age is above 18 years old. All right, so I'm gonna show you a bunch of repos. Like again, go to our GitHub organization. We have like a bunch of resources. This is a quick setup. So basically, if you just want to leverage what I showed, like very simply, and just have like on-chain use cases, everything is like in that repo. You can just use it as a template and start building with it. If you want to leverage more like the on-chain feature of it, like verify like proofs on-chain. Like you can go to our boilerplate app. It's like an example app with a voting logic. So it's like one Aadhaar, one vote. But you can like add any business logic that you want to that app, and just you have like here under contract, you have like a Solidity contract that you can change and just apply any business logic that you want. We also have like a circuit for DigiLocker. So basically inside of DigiLocker, you can like download any document in a XML format. And this document is actually signed. So the same logic that we are applying to Aadhaar, you can apply it to DigiLocker documents. Just a disclaimer here is it's quite heavy to compute. So depending on your machine, it can be like quite cumbersome to generate a proof. But here you can Salil build like a front end for that, and so you can like just without forking the repo and start building it, you can just go to that front end, try some stuff with some document, and then like if you think that it's like a good use case, you can then like start building on top of that proof. So we also have a Noir implementation. So I would recommend like Noir to be used only like for hackathon and with test data. But it's like in terms of UX, it offers like the same flow, but faster. It's just that for now we don't consider it secure. So again, like please, if you consider like using Noir, like don't use it with your real Aadhaar data. Just I can show you. We have a mocked data generator, and you can use like fake data. All right. So in terms of use cases, I think that the main use cases are like anti-Sybil mechanisms. So every logic around quadratic funding, quadratic voting, like actually Anon Aadhaar is like the perfect protocol for that. KYC, so basically I'm a platform and I need to ensure that my users are like more than 18 years old, or like they are from within a certain area in India. So I can get their PIN code and like do some checks based on that. Wallet recovery, I think it's like something in the community that we have seen, but we are not there yet. Vitalik wrote this article that he published like this week, and saying that as ZK email, Anon Aadhaar being another ZK wrapper category could also be set as a guardian. So meaning that, for example, you can think about it like you can has like your brother and your sister like as a guardian of your wallet based on their Aadhaar identity. So I think that's really cool, a really cool logic, and it's very powerful. And in terms of UX, it could be like what can enable like a lot of people actually using like Ethereum wallet under the hood. For that, I would suggest like to check ZK email stack. They did like a wonderful work about building a whole account abstraction stack on top of like ZK proofs. And also one other use case is like just anonymous credentials. So remember, with our DigiLocker circuit, now we can like generate proof that we have like a legitimate driving license. You can create proofs from bank statements or like tax reports. So I think that's gonna enable new type of credentials that like preserve your privacy, but still can be used in some business logic on-chain or off-chain. In terms of prices, we have like three prices, like two $1,000 prices and one $500 prices. In terms of judging criteria, like we're gonna judge in terms of use case, UX, and quality of the code. I think one error that we saw a bunch last year was so if you're using Anon Aadhaar, use it for the right purpose. So meaning that you want the user to be anonymous. Last year we had a lot of apps like doing Anon Aadhaar check as a normal Aadhaar check, and then asking like the name and the last name of the user. So again, if you're using Anon Aadhaar, use it for the anonymity purpose. And so your app shouldn't like add anything else than just Anon Aadhaar if you want to verify the identity. All right, I'm done here. I just wanted to show something. So yes, so in our document website, you can generate fresh data. So basically, it's emulating what the UID AI is doing, and so you can generate fresh signed data. So it's fake data, so it's gonna work. Again, it's just that the verifier will have to check the public key, and so like the verifier will say, oh, that's not the official public key, that's like a test public key, and so yeah, you can catch that inside of your app. Yes, I think I'm done here. Thank you.